In this video, I will explain how to draw a joint production possibility frontier, often abbreviated as a joint PPF. So let's consider the following scenario. Let's say that we have two individuals, Andy and Bob, and they're both capable of producing two goods, computers and shirts. Now the values in this table show different production possibilities. So if Andy specialized in making computers, he could make 8 computers. Or if he specialized in only making shirts, he could make 16 shirts. And similarly, if Bob specialized in making computers, he could make 4 computers. Or if he completely specialized in making shirts, he could make 12 shirts. Now, along with this information, I've also shown the opportunity cost for each individual of making each good. So for example, for Andy, the opportunity cost of making 1 computer is 2 shirts. So if he wants to make 1 computer, he has to give up the production of 2 shirts. And similarly, for Bob, the opportunity cost of making 1 computer is 3 shirts. So for each 1 computer that he makes, he's giving up the potential production of 3 shirts. And I've also listed the opportunity cost of making shirts for each of these individuals. Now, for a detailed explanation of how to actually calculate these values, I'll link to another video that I have. Now, once we have both of these bits of information, we have everything that we need to draw the joint PPF. So a joint PPF is simply going to be a graph that shows us the maximum combination of each of these goods that these two individuals could produce if they were both producing goods. So here's how we actually draw it. On one axis, we'll place one of the goods. So let's say we'll put the computers on this y-axis. And on the other axis, we'll place the other good. So let's say shirts will go on the x-axis. Now, we first consider the scenario where both individuals are only producing computers. If both Andy and Bob were only producing computers, how many computers could they produce? Well, that would just be 8 plus 4, which is 12. So one production possibility is that both individuals just make computers. And if they do that, they would make 12. So on our graph, on the y-axis, which is where we put the computers, we're going to mark the point 12. And what we'll notice about this point is that if both individuals choose to make computers, notice what production of shirts would be. On the shirts axis, we're at a level of 0 right here. So this is one potential production possibility. We could just make 12 computers and no shirts. And on the flip side, let's consider what if both individuals only made shirts? How many shirts could they make? Well, Andy could make 16 and Bob could make 12. So 16 plus 12, that's 28 total shirts. So if both Andy and Bob only made shirts, they could make 28 shirts. So we'll mark that point on the x-axis. And notice where we would be at on the y-axis. This would be at a value of 0. So this is another production possibility. We could make 28 shirts and 0 computers. Now the way that we actually start to construct our joint PPF is we ask ourselves, what if instead of making 0 shirts, what if we decided to make 1 shirt? So if we made just 1 shirt, which individual should make this shirt? Well, it should be the individual who has the lower opportunity cost. So for Andy, the opportunity cost of making 1 shirt is 1/2 of a computer. For him to make 1 shirt, he gives up the production of half of a computer. But for Bob, the opportunity cost of making 1 shirt is 1/3 of a computer. So for him to make 1 shirt, he only has to give up 1/3 of a computer, which is less than half a computer. So Bob has the lower opportunity cost of making 1 shirt. So that means Bob should be the one to make this shirt right here. And then if we ask ourselves again, okay, what if we make 2 shirts between these two individuals? Who should make this second shirt? Well, again, it should be the individual who has the lower opportunity cost, which is still Bob. And we can repeat this question over and over again. So who should make the 3rd shirt? Who should make the 4th shirt? And for each of these, we'll see that Bob should make these all the way up to his maximum potential production for shirts, which would be 12. So let's say 12 is right about here. But once we hit 13 right here, we'll notice that Bob is not capable of making more than 12 shirts. So his maximum production of shirts would be 12. And what we'll see is that if he did make 12 shirts, he would be giving up the production of 4 computers. So on our graph here, if we're at a point of 12, the number of computers that we would be making altogether would be 12 minus 4. So we're giving up these 4 computers. So 12 minus 4 is 8. So let's mark that right about here, 8. So this just tells us another potential production point. So we could make 8 computers between these two individuals and 12 shirts. So now we can draw a line connecting this point on the y-axis to this point that we just found. And once we've drawn that line, the last step is just connect this point to the x-axis. So we'll draw another line to connect that point. And what this tells us is that if we're moving from making 12 shirts all the way up to 28 shirts, the individual who should be making these 16 shirts will have to be Andy. And we will see that if he makes these 16 shirts, he's giving up the production of 8 computers. And that's exactly what we see on the graph. If we produce these 16 shirts right here, we're giving up this production of computers. Our production would drop all the way to 0. So these two lines together, this represents our joint PPF. And what it really shows is the maximum combination of both of these goods that could be produced if both of these individuals are producing goods. And one interesting thing to note is that the slope of this line right here, this represents the opportunity cost of the good on the horizontal axis, so shirts. So remember the formula for slope is rise over run. So in this case, we can see that the rise would be -4. So we went down 4 over run is from 0 to 12. And that simplifies to -1/3. And we'll notice that the absolute value of this slope right here is the opportunity cost of making one shirt for Bob. And remember, we said Bob would be the one to make these first 12 shirts. So this slope perfectly corresponds to Bob's opportunity cost of making one shirt. And similarly, the slope of this line is simply going to be the rise, which is -8, over the run, which is 12 to 28, that's 16. And that simplifies to -1/2. And the absolute value of this slope right here is the opportunity cost of making one shirt for Andy, which we said is 1/2. So remember, Andy would be the one that's making these 16 shirts right here. So that's how the slope of these two lines is related to the opportunity cost. So that was just a quick example of how to draw a joint production possibility frontier.